when fluids are used here, some factors need to be taken into consideration. Okay, so in order to find the work done by the gravitational force, first idea we need to know is that work of F gravitational is path independent. Do you remember this? It doesn't depend on what happens in between, so we just focus on initial and final. Yes? States. So because when I continue solving now, someone might ask, why is he doing it like that? Why didn't we simply take a certain mass and calculate the work done by it on it? In fact, whatever happens between these two containers, okay, doesn't depend except on the initial and the final situation. Okay, so we just work on the initial height and the final height. Now, how much water or liquid had been transferred from one tube to the other? Okay, so the work done by F gravitation is the work done to displace some amount of the liquid, okay, from one level to another. Okay, so liquid drops in the column in H2 and it increases in H1 to reach a certain height H. Okay, there is some amount of liquid here. There is this small amount of liquid here, this one. We can think about it as if it was the liquid here. So this liquid here was transferred, definitely not identically, okay, to this side. So we can think about it as if there is a certain bulk of liquid that was transmitted from this column, from this tube to the other tube. And the work done by the gravitational force is simply the work done to move this bulk, from here to here. Okay. Okay. Is there any problem at anyone, or things are fine? We can continue. Okay. Work done is equal to mass of this amount or sample times G times delta H, or height initial minus height final. That's how we calculate the work done by weight in general. And here we are simply driving that amount of water. Okay, excuse me, I'll have to mute. Okay. It's okay, it's okay. I've done it. Okay, don't worry. So the work done by gravitational force is the work done to transform or to move this amount of liquid from this container to that container. To do that, I simply use the equation of the work done by weight, which is mg times height initial minus height final. Now this amount, okay, height initial is h1, it is h2 in fact, okay, and height final is h, which is nothing but h1 plus h2 over 2. So this amount of water had been moved from this level of height h2 here, okay, over here, to a new level, which is this one, the new height h. Okay, so as if we are considering this amount here, I'm going to use red as well, to move it from this container to this part, to this region over here. Okay, now work done is, now we still have the mass of that amount. How much is that mass? Gravity is given. Height initial and height final are already found now. We can proceed from there. Yes? Now, how much water or how much, sorry, liquid had been displaced from here to here? The amount of the liquid. Okay, the amount of liquid transferred is, okay, we need to find the volume here, yes? Is volume of liquid equals density of the liquid multiplied, sorry, I'm calculating the mass directly now. Okay, excuse me for that. So volume of the liquid is area of the base multiplied by delta H, which is the height, this height. Okay? Now, and that height is equal, which equals area of base times the amount of the liquid that was moved from one place to another is simply this and divided by 2, which is H2 minus H1 over 2. Okay? Now, I need your help here, please, to continue calculating, because then density, then mass equals density of the liquid multiplied by volume displaced liquid, which is density of the liquid times area times height 2 minus height 1 over 2. Okay? Let's start with the calculation. If anyone has the calculator, please have it ready. Okay? So first thing, H2 minus H1 over 2 to calculate the amount of the liquid that was transferred is 1.56 minus 0.854 over 2. Do you have an answer for that, please? 0.706. Okay. Yes, divide by 2. So 0.353. Thank you. Okay, meters. Okay, Emil. Now we'll go to calculate the mass. Then mass equals density of the liquid is 1.3 times 10 to the 3 multiplied by volume, which we said is area. Where is the area? 4 centimeters square. So 4 times 10 minus 4 to become meter times 0.353. Okay, kilograms. Okay, I'm waiting for you, Emil, or anyone else. Okay, yes, thank you. 0.18. Okay, very good. 1836. Now here, since Emil added that point, when you have many decimal digits, always pay attention. I don't know if you're doing the test over Wiley or directly jotting that, but always pay good attention to the amount of significant digits that you add. So if you just keep this as 0.18356, if you include the whole digits, you will be on the safe side. Okay? So Emil and Christina, you both have the same answer. They are both correct, but you should always pay attention to the question if the question demands any certain amount of significant digits. Anyway, so I'll take this 0.1836, right? Okay. Times G, which is 9.8, multiplied by height initial minus height final. Now the final height here, okay, I'll go up. Height final is height 1 plus height 2 over 2, which is 1.56 plus 0.854 over 2. So instead the minus add plus and give me the answer for this part. Okay, so here height 1, which is 1.56 or the opposite, plus 0.854 plus, not minus, divided by 2. Okay, waiting for your answer. I'll just write H1, which is the higher, by the way. Height initial is 1.56. Thank you, guys. 2.17, thank you. Over 2. I think you forgot the divide over 2. Okay, over here we have 1.56 plus 0.854 over 2. It's going to be around, by the way, 1.5 times 1 plus 1 0.2.3. It's going to be around 1. The final answer is 0.6 altogether. Or the height, Christina? Okay, yes, 1.207 makes better sense. Okay, now if you multiply all that, Hussein suggested that, Christina is saying 0.635. If you can please calculate all these together and find the answer. So the work done is in June. It's okay, it's okay. Just do the math for all of this, please. 0.6. Okay, 0.635. Okay, so the work done is 0.635 joules. Now, I will go over the calculation. Yes, not now, later on, before I send this, so that if there is any mistake in calculation or a number that we have miswritten, I correct that before sending it. Okay, guys, thank you for that. So simply, the work done is 0.635 joules, which seems a little bit a low amount of work. But don't forget that the water or the liquid that we transformed or moved from this container to this container is of small amount. The area is 4 centimeters square. Okay? Moving on now. By the way, it's mentioning that we have people in the, no, there are not. Okay, it gave me now that we entered into the 10-minute span. If it happens that we are solving an exercise and we were kicked out during that, we directly log in into the same link, okay? So over here, we have a piston of cross-section area A used in a hydraulic press. So we have this piston of area A, okay? On a small force F is applied on the left-hand side. The whole liquid is enclosed. A connecting pipe leads to a larger piston of cross-section area, capital A. What force? Okay, this is something from grade 9, if you can still recall. So over here, we know that by Pascal's law, I know that you're not supposed to explain usually, okay, or principle. Pressure 1 equals pressure 2 because liquids transmit pressure. Liquids transmit pressure, right? Pressure equally. Okay, what force of magnet F will the large piston sustain without moving? So in order to balance the system, the pressure from this side should balance the pressure from this side. Therefore, small f over small area equals capital F, or the larger force over the larger area, then capital F equals A over small a multiplied by small f. Okay? Multiplied by small f. That's it. So this is the answer for the first part. Part B, if the piston diameter or the piston's diameters are 3.8 centimeter and 53 centimeters, notice the difference, what force magnitude on the small piston will balance a 20 kilonewton force on the large piston, around 2,000 kilograms on one side? So to do that, Okay, we can start from the same equation. Okay, we know that small f times small a balances capital F over capital A. I don't know why I've written here multiplied. It should be divide. Okay. Now, we need to identify the needed things here. We need to find what force would balance, right? So I need small f. Small f equals small a times large F over A. Now, okay, given diameter, area of a piston is simply pi times radius squared, which is pi times diameter squared over 4. Okay, that's okay, admitting all. Yes, for sure, Mia. Okay, yeah, let's repeat. Okay, I'll repeat this idea. Okay, sorry for that. Okay, so the first thing we need to balance in this is what's known as the hydraulic press. Okay, so to balance the two pistons, we need equal pressures. There is a main concept whenever you are dealing with a fluid, mainly a liquid, that the pressure in a liquid is transmitted from one side to the other integrally without any loss. Okay? Now, to balance, so I have an equation between the pressure on this side and the pressure on this side. The pressure on this side is F over A. We know pressure is force over area. Okay? I'll open the chat. In case of any problems, please directly, okay? I will be asking you every now and then for thumbs up or anything like that, just to know that we are on the safe side, okay? Fine so far? So, we need to balance the two pressures. Second point, okay, so after that, I continued with simple mathematics. In the second question, part B, we are given some force on the large piston, and we need to check what small force will balance that force. Okay, I go into calculations, starting by pressures are equal. So force over area here equals force over area here, and we proceed. Okay. Now, after doing that, I need to calculate the area of each piston because we are given that the pistons are circular by given diameter of each. So area of any piston is given by the equation pi times r squared. So going back to the equation implies F equals large fraction pi small d squared over 4 times large force or large piston, large area force over pi times d squared over 4. Why d squared over 4 in case you are asking? The radius is diameter over 2. Since the radius is square, yes, guys, I think our time is almost over, right? Yeah, so look what I'm gonna do. We'll close this and then come back to the same link, okay? Meanwhile, like 2 minutes, not more than that. No, it's fine, Hassan, don't worry about it, okay? Directly, we'll come back to this, okay? I will be writing the solution only, okay?